Hello and welcome back to Curtidas Math. So in this video, we're going to be looking at the multiplication rule within the laws of exponents. So before we get started, there's a little bit of vocabulary that we should refresh ourselves on. So here is just an example of a monomial. So it's a single term, and within the term, there are three different parts of it that we can focus on. So the first of it is this big number portion at the front. This is what we call a coefficient. Okay, so that's our coefficient. The next piece would be the x in this case, which is our base to the exponent. This is also a variable, but in this case, we're going to be referring to it as a base because exponent laws are what we're focused on. And here the x is the base of the exponent. So in other words, the exponent 5 is being applied on the x, which is what makes it the base. So switch to my green, and then the 5 over here would be called our exponent. Okay, so three main words that we're going to be looking at. So a base doesn't always have to be a variable. It could also be a number. The base just refers to what the exponent is on. Okay, so another reminder, exponents signify a repeated multiplication. Okay, so if we have 2 to the power of 3, that means we are doing 2 times 2 times 2. If we have x to the power of 4, it means we're doing x times x times x times x. Okay, so that is the difference between an exponent and a coefficient, which represents a multiplication, which is repeated addition. So just to contrast that, 2x means x plus x. We could also look at 3 times 4, or 3, 4, which means 4 plus 4 plus 4. Okay, so the positioning of our numbers here refers to what operation we're doing. The number itself refers to how many repetitions we have. So here you might hear me say, how many x's do we have? We have 4 x's. And I could also kind of make the same statement with the multiplication. How many x's do we have? We have 2 x's. The difference is this how many is really vague, and it doesn't specify what exactly it is we're doing with this how many x's. In this case, we are multiplying them, and in this case, we are adding them. And what operation we're doing, that can be found based on the notation of where the number is. So it's really important to understand what the position implies. So in this case, when you have an exponent, you are repeating your multiplication. And when you have a coefficient, you are doing multiplication, which means you are repeating addition. Okay, so a couple of things to remember, but the more you use it, the more it'll stick. Okay, so now we're going to go get right into it and look at some multiplying. First thing we're going to do is actually look at this example, and I'm going to expand this out and kind of explain it. So again, we have this exponent situation, so x to the power of 6, and exponents, as we had just said, is a repeated multiplication. So this x to the 6 can be expanded out like this. I just repeat a multiplication of x 6 times. All right, so I have 6 of them. And then I have this x to the power of 2. So I can repeat my multiplication again 2 times. Now here I have 2 of them. And again, I'm saying 6 of them and 2 of them. I'm not specifying. We know in this context, we're talking about 6 of them and 2 of them being multiplied because we have exponents. Okay, so now if I count them out, how many x's do I have in total being multiplied? 1, 2, 3, 4, 5, 6, 7, 8. I have 8 of them total being multiplied together. And since they are being multiplied, I put that 8 on the exponent. Okay, so what I just did here, my shortcut version, you don't have to do this expansion every single time. There is a shortcut. And if we look at the shortcut, we started with 6 and 2, or 6 and 2, and we ended up with 8. That shortcut is an addition. You can add those exponents together. Okay, so what our general rule is, here we have a to the power of m and a to the power of n. These two things are being multiplied. So if you want to be a little bit more specific with your notes, you could also put a little dot there to remind you that it's a multiplication. The most important thing here to recognize is that the bases match. This is an A with an A. It's not an A with a B, it's not an A with a C, it's an A with an A, which means these two things on the bottom, the bases are exactly the same. On top here, we have an M and we have an N. These two could be the same, but they don't have to be. Doesn't matter what M and N are, they're most likely different numbers. But what ends up happening is my base here, my A stays the same, I have the same base, and whatever my M is and whatever my N is, those two numbers, they will get added up together. And whatever that number is, that's your answer. So when you use this rule in practice, these will be numbers. M and N will be numbers, and you will not leave it like this. You will most likely have numbers, and you will actually add the numbers. Okay, this is just the rule to kind of show you how you get your number, you will add them up. Okay, so now if we look at the example 1 where we do have A's, in this case, my M is a 4 and my N is a 5. So what do I do with 4 and 5? I add them up just like my rule tells me to. So here, if I wanted to show my work, I can do a to the power of 4 plus 5, but remember that your final answer should have only one exponent. You shouldn't, unless you have like a variable up here, which is kind of a more advanced example, you should have a number. Okay, so now we can kind of go through this a little bit faster since that is the main meat of the rule. Over here we have b to the power of 5 times b. This is actually an important example. Here our b doesn't have an exponent written. When that happens, you need to remember that your exponent is to the power of 1. We don't write it because it's kind of the standard, the baseline. So it doesn't get written, but you do need to remember that it's there. Okay, so now we can add up our exponents since the two b's are being multiplied. So the 5 and the 1 get added up together, and that gives us 6. So our exponent is 6. For the next one, we have 2 to the power of 4 times 2 to the power of 2. So this is the example I was telling you that you could see a number as a base instead of a letter. That's totally fine. As long as our numbers match, there's no issue here. We can absolutely use our multiplication rule because our bases match. So we know that our base is going to remain as a 2, and we're going to add these exponents together. So 4 plus 2, that's going to give us 6. Now something that's special here is that since this is a number, you can actually simplify the entire thing. So here, find the answer. Because it's a number. So we can do that. This is 2 times 2 times 2, etc., 6 times, right? So this you can use your calculator. It'll be done in a flash. So over here I have it prepped. This is a picture of two very common calculators. So to do 2 to the power of 6, and in case you don't know how your calculator works, you will be using this button over here in order to get your exponent, your little hat. If you have something like the Texas Instruments calculator, then instead of the y to the power of x button, you will instead have this little hat button. So that's another way to see it on a calculator. And then there's also some calculators that have x with like a little box. That's another version of this exponent button. So anything beyond an exponent 2 or exponent 3, there isn't a standard button for it on your calculator. They usually stop at exponent 3, and then you'll have to use this exponent button to actually manually type in what exponent you want. So here our answer ends up being 64. Okay, and then the last one over here, we have z to the power of 8 times z to the power of 10. Those exponents get added to give us z to the power of 18. So that's it for the basic multiplication rule. So now we're going to go into a little bit more complicated. So here we have multiplying like bases with more than one variable. So now we have kind of a mix mash. So in this case, it is very, very helpful to use a calculator. So our first step is match up the like bases, same letters together. So I would recommend use a highlighter. That is, color coding is how I organize all of my work. I think it's just so much easier to see what I'm doing. So here I've highlighted my A's with my A's and my B's with my B's. So my A is going to become AM plus X, and my B is going to become BN plus Y. And the reason for this is a special property in multiplication. So we have, it's a fancy word, it's called the commutative property. So the commutative property really just tells you that shuffling is okay. So shuffle is okay. That's all it means. So because all of these, sorry about that, because all of these here are multiplied together, this is x to the power of 2 times y to the power of 3 times x to the power of 4 times y to the power of 2. All of those are multiplications. I can reshuffle them however I want to. I don't need to leave them in this order, the same way that 2 times 3 equals 6, 3 times 2 equals 6. So it's the same thing when you have letters involved. You can mix them around and kind of change the order, and the answer will still be the same. So if I wanted to, I could rewrite this as x to the 2 times x to the 4, y to the 3, y to the 2. And when I reorganize it like that, it's a lot easier to see our x's be collected and our y's be collected. Just a little way to visualize it. And then the rule is the same as the previous page. So they still get added up because they are being multiplied. So x to the power of 6 and y to the power of 5. So we just multiplied those exponents together. So for this, I'm going to continue these ones and I'm just going to color code. Instead of rewriting it, you absolutely can reshuffle it every single time if you wanted to, but you don't have to. You can just color code and make sure that you're matching up the right numbers based on the bases that they belong to. So here we have M and N. So for our M's, we have 5 plus 2. That's going to give us 7. For our N's, we have 4 plus 4, and that's going to give us 8. For your answer here, I have seen a lot of students add addition signs, or sometimes they put things like m to the 7 over n to the 8, because it tends to be a little bit confusing since there's no operation here. and it feels like these two are two separate things. They're not. This is a single term. It is being multiplied together. So you just need to kind of squish the letters next to each other. This is actually a little bit too much space that I gave them. I'm going to put them a little closer together. So m to the 7, n to the 8. They really are squished next to each other. Okay, now for the next one, we have our C's and we have our D's. So again, remember this C over here has an exponent of 1 that's not being written, but it is there. So when we add up the exponents on our C's, we're going to get C to the 6. And the same way for our D's, we're going to get D to the 8. Okay, the next two, the next example has 3 different variables. So we're just going to use 3 different colors, but the process is exactly the same. We add up those exponents. So for the A's, we have 2 plus 6. For the B's, we have 7 plus 8, which will give us 15. And for the C's, we have 10 plus 2, which will give us 12. So that is it. It's just an extra set of letters, which is not a big problem. The next one is actually one of the trickiest examples in the note package because there is an exponent, which is a variable. So for the x's, it's not a big deal. We have x to the 6 and x to the 1. Add them up, we get x to the 7. For the y's, however, it is a little bit tricky because here you have y to the 2 and y to the z. Now, it might be a little confusing of, well, how do I do that? I don't know what z is. How am I supposed to add it? Well, exactly like that. You don't know what z is, but you do know that whatever z is, it needs to be added to 2. So we just write that. That's all we know. 2 plus z. That's how we're going to get this exponent. Whatever z is, that's going to get added to 2. That's going to be the exponent for y. This is as much information as you have, so you can't get any more specific than this. Okay, and then for the z variable, you're going to have 2 and 5. That gets added up, so you have an exponent of 7. Okay, so that is it for the second page. Now we're going to move on to the last page with coefficients, and that will be the end of the video. So here we have multiplying like bases with coefficients. So now we have everything in the mix. We have coefficients, and we have different bases. So it's the exact same thing, except now we match up our coefficients. They get maybe their own color. Again, I highly recommend highlighters here. So here are 5, that's a coefficient, and 4, that's a coefficient. X to the power of 2, x to the power of 5. So I'm going to do the same thing as before, and I'm going to reshuffle everything and use that commutative property. So instead of having 5 times x squared times 4 times x to the 5, I'm going to write it like this. 5 times 4 times x squared times x to the 5. And now here it's a little bit easier to see. I can collect my numbers, my coefficients, and I can collect my variables with exponents, so my bases with exponents. So 5 times 4, we know what that equals. You can punch that into a calculator or you can do your mental math and know that 5 times 4 is 20. So that can get simplified. We don't need to leave it like this. They're not the same base, so we can't combine them and add exponents here since they're different numbers, but we know what the numbers are, so we can absolutely just multiply them together. And then for the x's, we have x to the 2 times x to the 5, and that is our standard multiplication rule, so we can just add those exponents up. And that is how this is done. So your coefficients get multiplied in number times number, and your exponents, you use that multiplication rule and add those exponents up. So for our rule here, we're going to have 10 am plus x and bn plus y. So the 2 and the 5, that's what got us our 10. 2 times 5. And the a to the m and a to the x, that's where the m plus x came from. B to the n, b to the y, that's where the n plus y came from. Okay. So the next one, we're going to highlight our coefficients, highlight our a's, highlight our b's. So first, look at your coefficients. 4 times 2. 4 times 2 is 8. Then a squared times a. Remember that a has an exponent of 1. So a squared times a to the power of 3. B squared times b to the 6. 2 plus 6, b to the 8. Okay, next one. Now we have coefficients with negative numbers. That's fine, we just multiply them as we normally would. Negative 2 times 7 is going to give us negative 14. 5 to the power of y times 5 to the power of 2. Oh, did I say 5 to the power of 2? Sorry, my bad. Y to the power of 5 times y to the power of 2. 5 and 2 get added up, and we get y to the power of 7. Negative 4, negative 2, those are both coefficients. We have a's and we have b's. So here, negative 4 times negative 2, that gives us positive 8. Those negatives cancel out, so just keep that in mind. A squared times a squared, the two 2's get added. We get a to the 4. B to the power of 5 times b to the power of 4. Those numbers get added, and we have b to the power of 9. And then we have one more like this. Negative 2 with 5. We have our x's, our y's, and our z's. So for our coefficients, negative 2 times 5, we have negative 10. For the x's, we have x to the power of 1 times x to the power of 2. Add those up, x to the power of 3. Y to the power of 2 times y to the power of 2. Add up those exponents, y to the power of 4. Z to the power of 5 times z to the power of 1, which is not written, but we know it's there. Add those up as well, and you get z to the power of 6. And that is it. Okay, so we looked at quite a little bit in this video. We went from our basic multiplication rule all the way to more complicated examples with coefficients and multiple bases. So if there's anything here that is still confusing, make sure to do the practice. That's going to help everything sink in. And if you need any more help, you can always come see me during office hours. Bye-bye, and see you in the next one.